we have these antiderivative questions. I guess I've been telling you that you have two techniques, in 5A, we have two techniques. The first one I call is change the way it looks. And we can do that either with trig identities, or we could do that with algebra. That's really the two instances that we look at so far. So I think we should take a look at number C. We did something similar to this in the past. I think we did something like this last week in class. Does anybody know how I'm going to change the way it looks? Let me show you what not to do. God, this is terrible teaching, but here's what you don't do. You don't find the antiderivative at the top, which is x plus x squared over 2 plus x cubed over 3 divided by the antiderivative of the bottom, which is x to the 3/2 times 2/3. This is wrong. What you've basically done here is you've basically made up a fake quotient rule. And that's not really how we want to do it. You can't make up your own rules, I guess. All we can do is find the antiderivatives that we know how to find. So we need to do is we definitely don't do this. And instead, we got to change the way it looks. So Terry, I see your solution there. I'm not going to follow that immediately. Does anybody have any suggestions for me besides what Terry privately suggested? Anybody? Separate it. I agree. So what I'm going to do, and this is what I mean by change the way it looks, write this as x to the 1/2, 1 over x square root of x plus x over square root of x plus x squared over square root of x. Okay. So I want you guys to take a moment to finish this problem. I'll give you a couple minutes here. And then we'll look at this problem in a slightly different way as well. But try this first. Hey, Cynthia, you finished yet? Not yet. All right. So first thing we did was we separated it. So we sort of took the common denominator, we split it up into 3 fractions. Then I converted the radical to exponential form. And then next, I'm just going to use the fact that if you have 2 things with the same base, like if you have a to the n over, or rather, if you have x to the n over x to the m, that's the same thing as x to the n minus m. So I'm going to use that fact. Okay. So this first term is just x to the negative 1/2. The second term is x to the 1/2. And this third term is 2 minus 1/2 is 3/2. So x to the 3/2 like this. Then we can just, we can now find the derivative of each piece because each function is a power function. So you could write this as x to the 1/2 times 2 plus x to the 3/2 times 2/3. That looks a little cramped. Plus x to the 5/2 times 2/5. Don't forget the plus c. Okay, so this is how we do this one. Is there any questions about this? Okay. There's another way you could do it. There are students that find all these workarounds because they don't like using the quotient rule and they don't like working with division. It's technically correct, but I want you to be able to work with both. You know, ideally, you'd have multiple ways of solving a problem. So the other way that you could do this problem, I'll do this one in green, is you could have rewritten the integral as 1 plus x squared. And instead of dividing by square root of x, you can multiply by x to the negative 1/2 like that. This is the same as the original question. And then you could distribute like this. So when you distribute like this, you're going to get x to the negative 1/2 plus x to the 1/2 plus x to the 3/2 dx. And that's really the same step as right here. So it's two sides of the same coin. You could do it either way. Does that make sense? Any questions? All right. Let's just do one more example for now. So try this guy, try D. And then I want to talk about something else.